Okay, this video is going to be on section 3.3, and we're going to dive deeper into graphing quadratic functions. So let's just start with just a little review here from chapter 2. You may remember that we learned that we could take one of our basic graphs, for example, this one right here, y equals x squared. So that's a basic parabola. That's kind of our starting point whenever we're talking about quadratic equations. And then we can add things to it, multiply, change the sign, and it shifts that graph around. So just for a little review, let's talk about what this parabola would look like in comparison to our basic parabola. So first of all, I noticed first this plus 7 out here at the end. We're basically adding 7 to the whole thing. So if you think about it, if f of x is our y, that's just going to raise the whole thing up 7. So the first comparison that we can make here is that it moves it up 7. Okay? And then we also learned that whenever you had a number being added or subtracted, like wherever the x is, like here for a quadratic we have x squared. This is a modified one where instead of just squaring x, we're squaring x minus 2. And if that is a subtraction, which in this case we're subtracting 2, it's going to move it to the right. So if it had been adding it, it would have moved to the left. So now we have our basic parabola, which starts out at 0, 0. You know, we've seen that before. This is our basic one. We have now shifted it up 7, and we've moved it to the right 2, so it's up in here. The next thing I notice is that we have a minus sign out in front. Do you remember what that does? That flips it over. So now instead of opening up, it's going to open down. And finally, we have the 3. We're multiplying the x minus 2 squared by 3, and what does that do? That stretches it vertically, so it's going to be skinnier than our original one. And I have the calculator here. I'm just going to pull that up. And I actually put both of these equations into the graphing calculator on the y equals. So there's the x squared. Here's our modified one. And just to show you that it worked, there we go. Here's our basic one. Opening up, centered at the vertex at 0, 0. And then here's the one that is opening down. Notice the vertex is at 2, 7 because it shifted to the right 2 and up 7, and it is opening down, and it's narrower than our original one. So that's just kind of a little review. This is going to tie into what we're doing today when we're talking about parabolas. We're basically just taking what we learned about shifting any graph around, because we learned these things, same things work if it's a line, if it's an absolute value, which makes a v. These same transformations would do the same thing. Just whatever your starting one is, it would move it up 7 to the right 2, flip it, and stretch it vertically based on what it started as. Okay, so but today we are focusing just on quadratics. So the graph of the function y equals a, and then in parentheses x minus h squared plus k is called a parabola. That's just another way to write a quadratic function. We've used that word quite a bit, so hopefully by now whenever you hear parabola, you're picturing that shape. The graph turns, which means that's when, you know, if we look up here at this one I drew at the top of the page, it's going down and then it turns up. The second one that was on our calculator, it was going up and then it turned and started going down. That point where it turns is called the vertex. And it is this point HK. So just like when we looked at our modified parabola up here, I said the vertex is at 2, 7. Do you see the 2 and the 7 in the equation? Right here. There's the 2, and that's the 7. And when we look on the calculator, that is the x and y coordinates of the vertex. Now notice it's x minus 2. The vertex itself is a positive 2, 7, and that we've talked about that before, that when you subtract a number from that x, it actually moves it to the right, which feels a little opposite than what you'd think. And when you have, if that had been x plus 2, it would have moved it to the left. So that feels kind of backwards, but just remember that the equation for a parabola is going to have x minus h, and so whatever number that is, it's the opposite sign as the x value of the vertex. We also have something that we call an axis of symmetry. We learned about symmetry a couple sections ago, where we talked about it's the line that you can fold it on. A parabola, the axis of symmetry is always a vertical line, and it goes through the vertex. So if it goes through the vertex, it's going to have x. The vertical line's equation is x equals, and since it goes through the vertex, it's going to be equal to h, whatever that x value of our parabola of our vertex is. So the axis of symmetry for the sample one would be x equals 2. And you can see, I'm sorry, let me pull the calculator up so we can see the one that we're talking about. This is the one that opens downward. If we drew a straight line right through x equals 2, do you see how that would line up and match itself? Okay, let's move on. Let's do a sample. So this is a whole new quadratic function, y equals x squared minus 8x plus 12, and we want to rewrite it in that form that we had up at the top so that we can pull the h and the k out. So since this one just starts with x squared, there's no coefficient on the x, there isn't going to be an a. A is basically 1. So now we look at these first two terms, and we're going to do something called completing the square. We've done that before for other purposes, but we're going to use it for this purpose. To x minus h squared, we want to figure out what would h be in this case. So what we're going to do is we're going to write y equals, and then the x squared minus 8x, and then leave a space. Okay, leave a space, because that's where we're going to complete the square. And then out here at the end, write plus 12. And this part right here, the x squared minus 8x, and then whatever we put in here, is going to be the part that is squared. And then out here, we're going to have the 12, and we're going to adjust the 12. Depending on what we put here, we're going to adjust the 12 by the same amount, but opposite. Notice this is all on the same side of the equation. When we completed the square before, we were working on two sides of the equation. So when we completed the square, we did the opposite. In this, or the same thing to both sides. In this case, what we fill in that blank, we're on the same side of the equation as what we add to 12, so we're going to add the same thing. Or I mean, we're going to do the opposite so that they cancel each other out. Okay, so let's figure out what needs to go in this blank right here. So you may recall, this is a little review, if I square a binomial, and that just means taking it times itself, so let's actually write that out. And then we can FOIL, we get a squared. Outside gives me ab, inside also gives me ab. So I add those together and I get 2ab, and then last times last is going to give me b squared. So when you square a binomial, you get this middle term that is equal to the square root of the first term times the square root of the last term, and then you multiply by 2. That is our negative 8x. Do you see that? So if 2ab is negative 8x, ab would just be negative 4x, dividing by 2. And we know that, so the ab has to be 4x. The x is the a, so that means the minus 4 is the b right here. So we just kind of did that backwards. We'll actually write that out here to the side in just a minute. So what do I need to add here in order to make that square? If we took x minus squared it, we would FOIL it out, and you'd get x squared minus 8x, And then last times last would be negative 4 times negative 4, which is plus 16. So in order for this to end up being x minus 4 squared, I need to have a 16 right there. You tracking with me? Actually, we don't have another sample in this. You will have some samples on your homework to practice this. Okay, so we added 16. We're on the same side of the equation. We can't just add a number to it. We've changed the value, but we don't want to change the value. We're just rewriting it. So that means we either need to add 16 to the other side, or we can just subtract 16 on the same side, and those two will cancel out. So by adding this, we're going to subtract 16, and that means that instead of adding 12, we're going to have minus 4 out here on the right by combining these two together. Okay, so complete the square, expressing it in this form. We've now expressed it in that form. Now, what if we were asked, what is the vertex? Well, now it's really easy to pull that out because we have our h and our k. H is right here. It's the 4. Remember, if we go back up and look at our standard, it's x minus h. So this is x minus 4, so h is 4. And then plus k is on the right, so that's our minus 4. And our axis is x equals, and you just take your h. Okay, that is completing the square. To get a standard form of the function, which has the x squared and the x term and the constant, and putting it into this form that allows us to pull out the vertex and the axis of symmetry really easily. And on this page, I just wrote a little formula for these. If you don't want to complete the square and you just have to find the vertex, h is equal to negative b over 2a. So in our last problem, which was x squared minus 8x plus 12, let me just write that up here. I probably should have put these on the same page so we didn't have to flip back and forth. So let's see, x squared minus plus 12. A is 1, right, because that's the coefficient of the x squared. B is negative 8, and C is 12. So this formula would tell us that h is equal to negative b. B is negative 8, so that'd be negative 8 over 2 times a. So we get 8 over 2, or 4. And if we go back up here, when we did the whole thing of completing this square, what did we end up with? H equals 4. So this is kind of a shortcut way to get h. And then when you want to find the k, in other words, the y value of the vertex, you would take f of h. Well, we just calculated h in this problem. So I'm going to just put equals 4 because that's what we calculated for our specific problem. To calculate k, we would take f of 4. And that means we plug 4 in for x, and we get 4 squared minus 8 times 4 plus 12. So we'd have 16 minus 32 plus 12. And hopefully that comes out, let's see, that would be 28. Yeah, that comes out to negative 4. And that was our h, or our k from above. Okay, so we found two different ways that you can find the vertex. You can do it by completing the square, and you get everything about the equation that way. If you want to know if it gets flipped, if you want to know if it is narrow or wide, you get kind of the whole thing here. If you're just looking for the vertex and you don't need to have anything else, you can just use this formula right here. Negative b over 2a, that gives you the x value, and then plug the x in to get the y that goes along with it. Okay, let's do one more way. So ways to find the vertex. Here's one, is completing the square. And then we did 2, which was using the formula. There's actually a third one I want to show you, and I'm going to do that with this sample problem before we move on to the word problem. And that is to graph it on your calculator. Oh, I got to turn it on. And I'm going to pause the video real quick while I type it. I'm just going to use the same formula we've been doing, the same quadratic function. Okay, so hopefully you're doing this with me and you have this plugged in to your calculator. I just used the same one. We're going to look at a third way that you can use to get H and K, and that is using your graphing calculator. So I have it plugged in. I'm going to do the graph. And let's just pretend like we hadn't already calculated the 4, -4. You can kind of visually, we can confirm, yeah, that looks like 4, -4, but we wouldn't know for sure. We could zoom in a little bit, maybe get a little more comfortable. We could even do trace. With trace, it puts a point, or you'll see the cursor kind of come down. And as it moves, you can see the X and Y values down here. But sometimes it skips right past that lowest point. You can see it's getting closer, 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 closer. And now it's starting to come back up. So it never really went to that very, very bottom spot, which is what we want. There is a function in the calculator that will get it exact. So it is another one that's under calc. So second and then trace, that's calc. And then we know that this one opens upward. If you didn't know, we know that because it starts with a positive x squared. And remember, with our transformations from chapter 2, if there was a negative in front, it'd flip it upside down and open down, but otherwise it opens up. So since it opens up, we know that that vertex is going to be a minimum. If we knew it opened down, then that vertex would be a max. But since it opens up, that's going to be a minimum. So we're going to use the function that calculates minimum, which is number 3. And this works similar. We've done kind of this methodology before when we've looked for other things. You go to the left side of the point that you're looking for. In fact, I think we have done some. Yeah, we did relative minimums in the last chapter. So we've actually done this before. And then you have to hit enter twice on the second time. So go to the left side, hit enter, right side, hit enter one more time. And you can see there's a little bit of an error. And that's because the calculator isn't actually calculating it directly. It is doing an iterative process where it goes to the left of it, goes to the right, goes to the left, goes to the right. So depending on what points you picked for the left side and the right side, it doesn't come out exactly at it, but once it hits a point where it knows to the left and the right, both of those are bigger, it stops. And so you can see it stopped just a little bit off of where it should, but this is enough to tell us that it is 4, -4. And so I'm just going to write the notes here. That was using calc. And then number 3 or 4, depending on if you're looking for the min or the max. We were doing the minimum, so that was number 3. If this was one that opened up, we'd be looking for the max, and that would be number 4. And then you side, right side, hit enter one more time, and that will tell you what that point is. Okay, so we've had 3 different ways to find the vertex. Let's do a word problem. Okay, a model rocket. So again, with word problems, I want you to think English first. So let's not get all hung up in, don't get hung up in the details. Don't get hung up in the math, by the details meaning the math. Don't try to start plugging in things or solving it. I want you to just understand the story. What is happening? Can you draw a picture? Can you visualize it? And make sure you understand what the problem's talking about, and then we'll start doing the math. And then after we've worked through the math, then we'll go back to English and make sure that what we ended up with makes sense. So let's just picture what's going on. A model rocket is launched with a velocity of 150 feet per second from a height of 40 feet. The function is, and then we're given a math function, gives the height of the rocket in feet t seconds after it is launched. So this function is going to tell us, if we plugged in a time in seconds, so 3 seconds, if we plugged in that for t, then we would calculate how high it is at 3 seconds. We could do the same for 2 seconds, 0 seconds, 5 seconds, whatever. Determine the maximum height of the rocket. So let's just draw a little picture. We have two variables. We have t, and we have s of t. And we're shooting a rocket off. We're already up at 40. We're not shooting from the ground. It says it's starting at a height of 40. And then over time, what's that rocket going to do? It's going to go up. And then eventually, it's going to start coming down, right? Because of gravity. So can you visualize that? So even if we're shooting it straight up, like if we were actually drawing a picture of what the rocket was doing, if it was going straight up, it would be kind of like that. It'd be going up, and then we'd come down, and then it'd go down to the ground. So this would be at 40 feet. It would go up however high it's going to go, and then it would come down, and then it would land on the ground eventually, even if it was just going straight up. Wind and stuff would probably make it not exactly straight. But in our graph, we're actually graphing how high it is based on time. So this isn't a distance, this is time. So at 0 seconds, it would be right here at the 40. And then at 1 second, it would be up here somewhere, up here. And then at some point, and I don't know what that is because I haven't calculated it, it is going to turn around and start coming back down. And that's what this point up here represents. So we are asked for the maximum height. So do you see that that would be this point right here? It's the vertex of our parabola that we've made. And this is a parabola. We know that because it has the x squared. So we can pull up our handy dandy calculators and in y equals put this formula. Now one thing, I'm going to pause while I do it just to keep the video from getting too long. Don't forget that this negative sign in front of the 16 has to be the one with the parentheses around it. That's going to give you an error if you use a regular minus sign. Okay, I'm going to pause, type, and then we'll pick back up. So do this on your own as well. Hopefully you have something that looks like this. And then we're going to go over to the graph, and we get something that looks like this. Not real helpful, is it? What's going on here? Remember, our window is set to the default of 10 to negative 10 in all directions. But if we think about what's happening here, our function is starting at 40. And so we haven't made the window big enough to see what's happening. We need to at least have it go up to 40, but it's going to go up higher than 40 before it starts coming down. So it sometimes takes a little bit of experimenting before you get the right thing. And we can see it does come down over here. So we don't actually have to change the y unless we just want to get rid of some of these negatives over here, which we could do that. So okay, so we're going to go in here. We said that on the x values, we could just kind of get rid of that left side of the screen. So let's make that 0. That'll just spread those positive numbers across more. And then for y, we don't have to have it go below the y-axis. You know, it's starting at 40, and then it's going to come down and hit above 0. For y value, we know it has to be at least 40. Let's just say 100, and let's just see what happens. And sometimes it's just kind of guessing and checking until you get the parabola to all show up. Okay, there, it's still thinking. There we go. It goes up, and then you see it goes off the screen and back down. And in fact, it looks like it goes quite a ways. So what do you think? Let's try 300. Okay, it's still going off the screen, so we need to go even higher. How about, do you think 400 is enough, or should we go to 500? We just want to get it to the point where we can see the whole parabola. So we probably could have gone a little lower than 500, but that gives us a nice view of the parabola. And now we can do, just like we did on this is the third method that we used a while ago. This opens downward, so we're going to find a max. And we need to have that blinking cursor on the left side of the vertex. And then move it over to the right side. There we go. Hit enter twice. Okay, and I didn't put how to round your problems in my math lab. Will tell you how to round. This obviously doesn't come out even. Which number do we want? Do we want the 4.687 or do we want the 391? It depends on what it asks. Let's remember the x is our t, which is time, and the y is the function, the s of t. So that's our height. What were we asked for? We were asked for the maximum height, so that is our y. I'm just going to say round to the nearest foot? It didn't say, so we'll add that now. And so if we round to the nearest foot, that would be 392. Okay. And by the way, on the test, I did see quite a few rounding errors. And so I was able to give points back. If you missed the whole problem in my math lab, you got some points back if it was just a rounding error. But you really need to pay attention. You didn't get all the points back because that is part of it. So rounding to the nearest number, our whole number would be 392. The 10th would say you round here at this first decimal, which would round up to a 0.6. 100th has 2 decimal places, so it would be 0.56. And thousandths has 3, and that 2 would bump up to 3, so it'd be 391.563. So pay attention, especially on those tests, because you don't know if you missed it or not. When you're doing the homework, you put it in one way, it kicks it back, you can do it again, but on the test, you don't have that option. Okay, this problem could have asked a couple other things, so I kind of want to go ahead. I know this video is getting long, but I think it'll be helpful because you're going to see these in homework. What if it had said how long until it reaches the top? In other words, what time, how much time? And that would be the x value, which is, let's just say we'll round it to 4.7. And that's in seconds. What if it said, when will it hit the ground? Let me scroll up a little if I can. There we go. That would be the point over here where it intersects with the y-axis, or I'm sorry, the x-axis. So I'm going to change my window so that I can see that point a little better. Right now, I have this not going below the axis. I'm going to go 50 down. That needs to be a negative 50. So we can see that area over there. That lifted the axis up, and then we can see where it crosses. And do you remember what we used to find the x-intercept? It's another one of these functions. It's the 0. And a few of you missed that on the test. Finding the 0 of something means setting it equal to 0. And so if we're setting the function equal to 0, that is when y equals 0. And we do that same kind of process. We start on the left side of that point, and then I hit enter, move it to the right side, enter one more time. And you can see that this is like 0.000000. Again, it's that little error with the y, but the x value is 9.63. So if we had to round to the nearest tenth of a second, that would be 9.6 seconds. So does that make sense? Does it make sense that it would reach its height at 4.7? It would go ahead and come the rest of the way down 9.6. That seems pretty reasonable. So there we go. Those are a couple other things you might be asked in a problem like this. Okay, that's it for this section.